database management system, and how we collect the data, and how we clean the data, then we restore the data in the database. The main objective of this unit is a student can learn the data and different types of data and the process of data, and demonstrate and visualize data using graph, and interpret data for decision making process. These are the basic objectives of the organization of data. So what is actually data organization? Organization means the general structure of the items. Here data organization means it is a process of organizing raw data by classifying them into different categories, and this raw data includes the observations of variables. For example, arranging the marks obtained by students in different subjects is data organization. Suppose in a classroom there are 60 students and they are getting the marks in a particular subject, suppose mathematics, 10, 20, 40, 50, 60, like that. And if we are writing this data, just simple 10, 20, 30, 40, 50, it is having no meaning. If we arrange that data, the students of the marks, in a tabular format, then anyone can understand what is the roll number, what is the name of the, if we are taking the name of the students, and the marks in the particular subject. So that is the meaning of this organization of data. And data is the important asset for every organization. As time passes and our volume of data increases, the time consumed to search for any information from the data source increases. If it has not been organized already, let us consider the following example to understand the concept and the need for data organization. If you are not arranging the data in a particular order, it is too difficult to retrieve a particular record as and when it is required. It is a difficult task when the volume of the data increases. Suppose in an organization there are only 100 employees working together and their data is stored in a sequential manner. If it's not sequential manner, then it is too difficult to retrieve a particular employee ID. On the basis of the particular employee ID, the employee's information. What is the date of joining? What is actually the salary? What is actually in which department he or she working? That's a difficult task. So we can arrange the data in a systematic order so that anyone can easily access that data from the database. Data organization is the way to arrange the raw data in an understandable order. Organizing data includes classification, frequency distribution table, picture representation, graphical representation, etc. So what is the meaning of this actually frequency distribution here? Suppose we are collecting data, raw data, from a survey, and from that survey, the raw data can arranged first classification. We have to classify the data, whatever data we collect, and then we can arrange that in a tabular format. And then we can represent to the public in the picture representation format or graphical representation format. So that is known as the organizing of data. Let us consider, for example, I am collecting data, how many people in a city are used, which bikes, which company bikes. So it's too difficult to predict something. So I am taking a particular place where many people are passing in a day. I am taking a time interval. In that particular time interval, in the official time, suppose official time, then I am taking records in my pen and paper. How many people passing that way, in which time they are writing, and then at last in that particular interval of time, I am collect the data, and then I can arrange the data. How many people passing with the bike? The company name is Hero Honda. How many people passing on that way with the bike? TBS. the company is TBS. Then how many people are passing in that way on the bike, the company name Bajaj. In this way, if I am collect the data and then you can represent that data is valuable to the public. So what are the demand? What is the demand of the bikes for which company? That is the requirement of the data. So data organization has to arrange the data in order that we can easily read and work. It is difficult to work or to do any analysis on raw data. Hence, we need to organize the data to represent them in a proper way. Suppose students are getting marks, final year marks in the class 10th, and the school principal is needed to analyze the data. If the data of the students are not ordered or in a particular order, it is too difficult to analysis. If you are arrange the data in the mark basis, percentage basis, then we can easily say, sir, these are the students. This must suppose a number, you can predict these are the students are getting 90%, these are the students are getting 70%, these are the students are getting 80%. So we can analysis how many students are appeared and how many students are getting higher percentage, how many students are getting lower percentage. Then we take a benchmark of this analysis and plan for the next year. How to increase, how to improve our pass percentage as well as the result, good result. So that's why data is very, very essential for an organization and, and how the data is organized. Data is nothing but systematically recorded values and facts about a quantity. When the data available to us is not systematic or organized, they are known as raw data. So whatever the data we collect from a survey, it's called the raw data. Mostly the data given to us is in the form of raw data, and systematically organizing them may be in the form of either bar graph, pictograph, double bar graph, or any other form of visual representation is called as organization of raw data. So whatever data we collect, it is our job. We have to analyze the data, clean the data, store the data for the future purpose for different analysis, different types of analysis. Then purpose and benefits. What are the purpose and benefits of the organization of data? The first benefit is enhanced accessibility. Organized data is readily available and can be quickly located when needed. That is the first benefit. That's why you are arrange the data in a systematic order. Suppose roll number, student name, class, and different marks, different subject marks in a order. If we are arranged, it is easily access a particular data of a student very quickly because they are arranged in sequential order. Improved usability. A structured format allows for easier analysis, interpretation, and understanding of the data. If the data is arranged in a particular format, in the one particular format, it is easy for analysis. Suppose, for example, we are collect the data of different stores of a particular company. Let us consider one company XYZ having different stores in different locations, and suppose one store is outside India and number of stores are inside India. In inside India, what are the items sale and, and the item name, the quantity and the price is mentioned in the rupees. In outside India, the same thing, item name, quantity, what is the price in dollar. If I collect that data in rupees and dollar, it is mismatch. We cannot store the same data of different stores in one format, in one database. It is our job. We can convert dollar into rupees or rupees into dollar in one format we can store in our database so that it is easy for analysis and anyone can understand the data. Then facilitated research. In research, organized data helps in understanding complex information, identifying patterns, and drawing meaningful conclusions. For the research work, organized data helps to the researchers to generate patterns, and on the basis of that pattern, they can conclude and draw some meaningful information. The next one is efficient data management. Organization streamline the process of collecting, storing, and managing data, and making it easier to work with large data set. So it is the how to streamline the process of collecting, storing, and managing data is the important part. How effectively we can manage our database is the advantages to different users. That's why we need organizing of data and the benefits we understand. Then the key methods and techniques. What are the techniques we can use, we can implement it for the organizing of data? First one is a classification. Grouping data based on similar characteristics or attributes. That's the grouping. Grouping is very important. That is known as a classification. Suppose in a school there are 120 students appeared 10th examination. So 120 students are not in one class. If we classify that data of the students into section wise, that is one the classification. That is the meaning of grouping data based on similar characteristics of or attributes. Similar characteristics, attributes means the student is the similar type and their marks are also different, but they are grouping in different section wise. Section A, 60 students. Section B is 60 students. Section C is 60 students. In this way, can analysis which section students are result more, which sections students are not getting up to the mark. Then we can focus on that section students, how to improvise their result. Then tabulation, arranging data in a structured format like a table or spreadsheet. As we know, data is the raw facts and figures which processed and generate information. And tabulation here means we can store your data in a row and column-wise manner. Rows are always records, columns are always fields. So we can arrange data in the records and fields. So it is called as a tabulated format. So we are using different softwares, just like spreadsheet, Excel, MS Access, everywhere data are arranged in a tabular format. The third one is hierarchical structure. Organizing data is in a hierarchical structure with both topics at the top level and subcategories at the below. That is the meaning of this hierarchical structure. In an organization, if you consider an example, in an organization, there must be top level peoples. They may be the director, board of members, chairman, like that. Under that, there are a number of managers, middle level peoples. Again, under that, there are so many supervisor level peoples working together to monitor the ground level peoples, low level employees. In this way, how the structure of an organization, organizing data is a hierarchical structure. From the top to bottom, we have to categorize the data. Then folders and files. Utilizing folders to group related files and applying clear, consistent naming conventions. Always we store our data in a file, and the files are stored in a folder. Then database management system. As we know, DBMS is a concept that it facilitates to the user to interact with the database. Database management system means it is a software actually. With the help of this software, we can create our database, we can manipulate our database, we can store our database permanently for a long period of time. So this is known as a DBMS, and DBMS is that software which provides the interface between the user and the database. So using DBMS, we can store, manage, organizing data in a structured and efficient manner. That is the meaning of this DBMS concept, database management system. Then examples. In research, organizing interview transcripts, field notes, and other data collected during a study. The interview data, field notes, other data collected during the study are used for the research work. In business also, structuring customer data, sales data, or financial records. These are the data are very important to run an organization, to run a business organization smoothly. For making a profitable organization, it is very important to know what is the sales data, day-to-day basis, and all the financial records and customer details. In computer science, organizing data for storage, retrieval, and analysis in database or data warehouse. In this way, the organizing of data is helpful for different purposes. So data warehouse means large number of data can be stored for a long period of time, and data warehouse in general means the present data and the past data is stored permanently, which is needed in the future. Then consideration. If you use the database, these are the three components are very important. We can consider it. First one is consistency, maintaining a consistent naming convention and structure for all data. Data integrity, ensuring that data is accurate, complete, and consistent. Here, consistency means integrity means no one can allow without permission to access the database. Means unauthorized person cannot modify anything in our database. Data security. Data security means protecting sensitive data with appropriate access control and security measures. So these are the three important components we can consider in the concept of organizing of data. Then types of data. As we know that data are the raw facts and figures which are collected through different sources. After collection, it is required to process and identification of correct data. So, data collection requires processing and identification of correct data. Accurate and processed data is used in research process. For accurate decision making in the organization, perfect plan of data processing is needed. Data collection is a crucial step in research process and involves the identification and processing of relevant data. Once data is collected, it needs to be processed and analyzed to derive meaningful insights. The accuracy of data is important for reliable research, results, and informed decision making in an organization. So data collection is an important part because accurate data, if you are collected, it is valuable for the research, for the decision making process in an organization. And accurate data is very, very important for any prediction. on the basis of different types of analysis. So data processing involves several steps, including identification, coding, comparison, and preparation of charts, among others. Proper data processing ensures that data is organized, structured, and analyzed in a meaningful way. Then I am again inform you data processing contains identification, coding, comparison, and preparation of charts. As data is available in various forms, these forms and formats improve the use of data because the right of format improves data management. So that's very important concept. So data are collected in different sources. It may be primary sources or secondary sources, and in different formats. So we can integrate all the formats to a single format, and then it is will be validated, and the validated data or information will store permanently in the database management system, in the database. And in the types of data, first we discuss about the quantitative data. Quantitative. Quantitative means numerical value. Suppose I am pushed to a shop and purchase 1 kg of sugar. At the evening I am paying, that is the 42 or 45 rupees. So what is the meaning of this? What I am purchasing? I am purchasing sugar, that is your data. And how much sugar? 1 kg. 1 kg is the numerical information. So quantitative data means must be measured in numerical structure. Is characterized by its ability to be expressed in the numbers and analyzed using statistical methods. Example include heights, weight, age, temperature, and income. So these are the examples. Height is measurable, weight is measurable, age is measurable, temperature of the day is measurable, income of the employees are measurable. So hence it is a quantitative data. Then the characteristics of quantitative data. The first characteristic is numerical. Quantitative data is always expressed using numbers and numerical values. 5 students attending the class today. At the 5 is the quantitative data. Then countable and measurable. It represents things that can be counted, like the number of students in a class, or measured like the height of a building. That is not the countable or measurable. Then statistical analysis. Quantitative data is suitable for statistical analysis, allowing the researchers to identify patterns, make comparison, and test hypotheses. Then data are of different types. Discrete data, continuous data. What is actually continuous data? What is the meaning of a continuous data? The data can be measured on a continuous scale such as height, weight, and temperature, each known as continuous data. Then discrete data. These data can be counted in the whole number, such as the number of cars in a parking lot or the number of students in a classroom. Now that is the meaning of this discrete data. Then examples of quantitative data. Age of individuals in a survey, the number of visitors to a website, the average temperature in a city, the amount of rainfall in a specific region, test scores of students, and sales figures for a product, income level of different demographics. Uses of quantitative data. Why we are using this data? Quantitative data is crucial in scientific research for testing hypotheses and identifying trends. Decision making. Business use quantitative data to analyze market trends and track performance and make informed decisions. Then problem solving. Quantitative data helps identifying problems and develop solutions by providing numerical evidence. Then policy development. Government use quantitative data to analyze social trends, develop politics, and allocate resources. So these are the uses of quantitative data. So in the decision making process, the quantitative data is very, very important. In problem solving process, quantitative data is also identify the problems, develop solution by numerical evidence. And it is also useful in policy development or policy making process because it is required to analyze the trends. Then other type of data is known as the qualitative data. Quantitative, numerical values must be there, it is measurable. Qualitative, it is not measurable, no numerical value. Qualitative data is descriptive information that focuses on understanding qualities, characteristics, and concepts rather than numerical values. So, no numerical values are there in the qualitative data. Then characteristics. Non-numerical means what qualitative data is not represented by number or measurements. Descriptive, it focuses on describing qualities, characteristics, and concepts. Then, meaning centered, it aims to understand the why and how behind behavior and phenomena. Then, subjective, it often involves individual perception, experience, and perspectives. Then, the last one is in the depth. Qualitative data provides details, information, and context. Examples. Transcripts of interviews or focus groups, open-ended survey responses, field notes from observations, photography or images, and audio or video recording. So these are the examples of qualitative data or information. So types of qualitative data. There are two types of qualitative data. One is a nominal, another is a ordinal. Data categorized without a specific order or ranking is known as nominal. Means example is colors of the cars. Ordinal means what? Data categorized with an implemented order or ranking. Example, star rating. Analyzing qualitative data. So how to analyze? Identifying patterns and themes, content analysis, thematic analysis, and grounded theory. These are the different processes we are implemented for analyzing the qualitative data. Identifying patterns and themes. Researchers analyze the data to find recurring ideas and patterns. Then content analysis. Examining the text for specific words and phrases or concepts. Then thematic analysis, identifying recurring themes and patterns in the data. And grounded theory, developing theories based on the data collected. Then data processing. In data processing, we discuss in these slides what are the different steps we are used for data processing. Data processing is the art of converting raw data into a usable and meaningful format. The data which are collected is known as raw data, and it will be converted into a usable and meaningful format, generally in tabular format. Typically, for analysis or decision making, it involves various steps from collecting and preparing the data to cleaning, transforming, and analyzing the data. The goal is to extract insights and knowledge from the data that can be used to inform decisions or improve processes. Steps in data processing. There are various steps for data processing. Number one, data collection. This involves gathering raw data from various sources, such as databases, sensors, and manual entry. So, first job is in the data processing is the data collection. We can collect in different way or different from different sources, such as from database, maybe it is sensor data, maybe manual entry. If a data entry operator enter the data into a server, it is called the server data or database, one database, and it is easy to retrieve the data from the database. Data preparation. Data preparation means cleaning. This step involves removing error, inconsistencies, or irrelevant information to improve data quality. That is the data preparation. Remove the inconsistency data, which is no meaning. Remove the errors, then improve the data quality. That is very important. Data transformation. This involves converting the data into format that is suitable for analysis, such as storing, aggregating, or summarizing. So this is not your data transformation. What about the example I have explained just earlier? Different stores of, taking an example of Reliance Industry, are collected and stored in a single database. At that time, it is our job, we have to store in a single format. Means dollar, if the price is mentioned in dollar, we have to convert dollar into price. If the price price is mentioned in the rupees, we can convert a rupee into a dollar. It is our job. Then after transformation, we can store our data. Then the fourth one is your data analysis. The fourth one is your data analysis. This step involves statistical methods or measures or other analytical techniques to extract insights and patterns from the data. Here, data analysis is the important part. The statistical measures such as we know, mean, median, mode, variance, range, standard deviation, etc. And these measures can be done by using the software. Nowadays, many students, many organizations are used R programming, Excel to give the informations about the analysis. Analysis are of different types. demographic, diagnostics, then predictive, then prospective. These are the four types of analytics or analysis we are used in different organizations for different purposes. Demographic analytics or analysis gives the idea what happened in the past. What happened in the past. And diagnostic analytics give the information about why it happened, means the root cause, why it happened. And predictive means we have to predict a trend, generate a pattern, in which direction we are moving. Is it right or wrong? That is the prediction here. Then prospective. Prospective means if predictive is there, prospective must be there. We have to plan how to achieve the goals which is mentioned in the predictive analysis or analytics. Then data presentation. The process data is presented in a clear and understandable format such as charts, graphs, or reports to facilitate decision-making process. So these are the four concepts. Is very very essential to for every members. That is charts, graphs, or reports, or to facilitate decision-making process. Then types of data processing. Data processing can be done in two ways: batch processing, real-time processing. What is the meaning of batch processing? For example, I am explaining here. We first collect the data, keep in one place, and that data will be processed later on. It's known as sequentially, that is called the batch processing. Real-time processing means data is processed immediately as it is collected, often used in applications like financial transactions or streaming data. That is very important here. Batch processing means batch-wise. Suppose in the earlier days, that will happen in the earlier days in the bank, in every bank. Batch processing in the bank means customers are moved to the bank and submit the check. At that time, it will not immediately process. It takes 2 to 3 days time to process your check. Because at the evening, the cashier collect all the DD or draft or checks and process at the evening. Batch wise means from top to bottom. That is another batch processing. Real time means immediate processing. That is the online is a real time processing system. ATM is the online processing system. Means if a customer withdraw money immediately, that will be reflect or updated in the bank passbook. And both the participants, your bank also know and you also know what is the amount balance is available in my account. That is the meaning of real-time processing system. Data is processed immediately as it is collected and often used in applications like financial transaction or streaming data. Then we discuss about business analytics, machine learning, scientific research. Anyway, as we discussed, business analytics, there are four types of business analytics for analytical process: demographic, diagnostic, then predictive and prospective. Analyzing sales data to identify trends and predict future performance, we need business analytical process. Machine learning training models to predict outcomes based on historical data. And scientific research analyzing experimental data to draw conclusions. is known as the example of data processing in action. Researcher, data analyst perform editing, coding, and tabulation, classification, and make data clean in data processing process. Data processing makes editing of data simple and give a way to researchers for moving forward in the right direction of data entry. Whenever researchers find missing entries in collected data, filling missing entries may not valuable. There has to be inconsistency faced by the researcher. Hence, data processing becomes very important task. So, the job is you have to collect the data and to store the data, and you have to classify the data, edit the data, tabulate the data. These are the different processes we are used in our database. So these are the type examples of data processing actions. Then basic functions of data processing. Already we know that coding is an important part of the data processing functions. Coding of data refers to the process of transforming collected data or observation to a set of meaningful cohesive categories. It is also process of summarizing and representing data in order to provide a systematic account of the recorded or observed phenomenon. Data coding is the process of deriving codes from the observed data. In research, data is either obtained from observations, interviews, or forms of questionnaires. The purpose of data coding is to bring out the essence and meaning of the data that respondents have provided. Then the last one is later in the evaluation of data, the researcher, the data analyst again assigns values, percentage, or other numerical quantities to their codes to draw inference. So this is the one example of coding of data. I am preparing a table here. Variable information, option, and code. And under that variable information, the first one is a gender, age, qualification. So in option, gender means we may consider male or female. So I am writing here male and female. And I am putting the code is 1 and I am putting the female code is 2. Age. Age again, categories like that. Less than 25, 1. 26 to 35, 2. 36 to 45, 3. Greater than 45, that is 4. That is the age category. Similarly, classification, HSC, diploma, undergraduate, postgraduate in the Calcutta. And the code we have mentioned, HSC pass out means 1, diploma pass out means 2, and undergraduate pass out means 3, and the postgraduate is pass out means that is the 4. So these are the qualification. We have to categorize and put the code. Income monthly. Similarly, less than 25,000, 1, 25,000 to 50,000, 2, 50,000 to 1 lakh, that is 3, and above 1 lakh, that is one of the 4. So different categories are there, that is one of the coding. Data presentation for clearer reference. Broadly, there are 3 methods of data presentation. Data presentation is an important aspect of research as it allows researchers to convey their findings and effectively. Then, textual data, textual presentation. This involves presenting data in the form of written words. Text data means in the form of word, paragraph, sentence, like that. This method is commonly used when the amount of data is small or when the researchers wants to highlight specific details or findings. These are the qualitative data. We can represent data in the form of words, sentences, and paragraphs. And this method is commonly used when the amount of data is smaller or when the researchers wants to highlight specific details or finding. Then tabular representation. This method involves organizing data in a table with each row representing a case or observation and each column representing a variable. Tabular presentation is useful when dealing with a large amount of data. It allows the researchers to compare and contrast different variables easily. Then graphical presentation. This method involves presenting data in the form of graphs or charts. Graphical presentation is useful when the researcher wants to show patterns, trends, or relationship between the variables. Graphical presentation can make it easier for readers to understand and interpret the data specifically when dealing with complex data sets. Common types of graphs include bar graph, line graphs, scatter graph, plots, pie chart, etc. Graphical presentation of data, also known as data visualization, and it is the process of transforming numerical data into visual format like graphs, charts, and diagrams. Graphical presentation has been divided into further categories. Suppose we have collected data, the sales data of a particular showroom. Let us consider one example, Honda showroom. There are different types of bikes they sell in the showroom. There is a Honda, Shine, Activa, and other categories are there. And in a particular week, after a particular week, if you collect the data on that week, how much, that's the question mark, how much Activa sold out, how much Honda Shine sold out. In this way, if we have to collect that information after processing, and we are not representing in a tabular format, it's too difficult to understand. And after tabular format, sometimes it is necessary to represent the processed data or information in the form of graphs, charts, and diagrams. So anyone can understand easily. That's why graphical presentation is very important. It plays a vital role in every organization. Then what is actually graphical presentation and what are the different types of graphical presentation? That is a bar chart, line chart, pie chart, histograms, scatter plots, box plots, frequency polygons, OGIFs, cumulative frequency graph. So bar chart is what? Use rectangular bars to compare different categories or values. Line graphs display data over time, showing trends and changes. Pie chart represent parts of a whole using slices of a circle. Histograms show the distribution of continuous data using bar. Scatter plot displays the relationship between two variables. Box plots summarize data distribution using quartiles. Frequency polygon shows the distributing of data using connected points. And OGIFs is the cumulative frequency graph represents cumulative frequencies. So these are the different types of graphical presentation. The benefits of the graphical data presentation. The major benefits are enhanced understanding, data becomes easier to grasp and remember, improved communication, effectively convey complex information to a wider audience, faster analysis, quickly identify trends and patterns, more engaging presentation, make data more visual appealing and memorable. So these are the different benefits of the data presentation. Then this is a figure and a table is mentioned in the slide. What is actually a line graph? Line graph is used to show how the value of a particular variable changes with time. We plot this graph by connecting the points at different values of the variable. It can be useful for analyzing the trends in the data and predicting the future trends. Means either future trend means it may be increase or it may be decrease. We have to mention in a particular point. That is the meaning of this. Line graph is useful for analysis purpose or graphical representation. Let us consider there are two variables x and y. X is mentioned as 1, 2, 3, 4, and y is 300, 500, 100, and 200. If I am taking a graph paper and plotting that graph and join the points, it will be a line graph. That is x equal to 1, 2, 3, 4, y equal to 300, 500, 100, and 200. That is actually data and the line chart. Similarly, bar graph is like that. I am taking one example. X and y, 1 equal to 300, 2 equal to 500, 3 equal to 100, 4 equal to 200. Bar graph is a type of graphical representation of the data in which bars of uniform width are drawn with equal spacing between them on one axis. X-axis usually depicting the variables. So looking to the graph here, in x-axis we are taking 1, 2, 3, 4. In y-axis we are taking 300, 500, 100, 200. And if you are plotting the marking on the graph and we draw the bar graph, it indicates, it can conclude, it can gives, it can insights the valuable information generated from the data analysis. Similarly, histograms. This is similar to bar graph, but it is based frequency of numerical values rather than their actual values. The data is organized into intervals, and the bars represents the frequency of the value in that range, and that is it can count how many values of data lie on a particular range. That's why I mentioned that is x equal to 5 to 25, 25 to 45, 45 to 65, 65 to 85, and the items are 6, 8, 3, 3. If you are plotting the graph, histogram, that is like that. Like histograms, other graphs are also there. One is your line plot. This is one example. I'm taking x and y two variables. It is a plot that display data as points and check marks above a number of lines showing the frequency of the point. So x is 1, 2, 3, 4, 5, and y equal to 2, 3, 1, 2, 0, and that will be plotting in the graph shown below. Then pie chart, it is a type of graph which represents data in the form of a circular graph. The circles is divided such that each person represents a proportion of the whole. The percentage wise, the data will be represented in different colors in the pie chart. Box and whisker plots. These plots divides the data into four parts to show their summary. They are more concerned about the spread, average, and median of the data. That is called as a box plot. Then frequency polygon. Frequency polygon is a graph that is constructed by joining the midpoint of the interval. The height of the interval or the mean represents the frequency of the values that lie in that interval. Let us consider one example I am explaining here. The frequency is taken in y-axis and the class interval is taken in actually x-axis. I am taking joining the point. I am taking the points and join together. It is called as your frequency polygon graph. Then column chart. Some of the most commonly used column charts are best used to compare information. Or if you have multiple categories of one variable, for example, multiple products or genres, Excel offers 7 different column chart type: clustered, stacked, again clustered, 3D stacked, like that. And these are the visualizations of cluster column, stacked column, 100% stacked column, like that. So anyone can understand and conclude something by looking into the graph or chart. Then bar chart is the bar chart. And what is the difference between the bar chart and the column chart? The main difference between the bar chart and the column chart are that the bars are horizontally instead of vertically. You can often use bar charts interchangeably with column charts, although some prefer column charts when working with negative values because it is easier to visualize the negative vertically on a y-axis. Then pie chart is like that. There is the figure. Use pie charts to compare percentage of a whole. Each value is represented as a piece of the pie, so we can identify the proportion. There are 5 pie chart types: pie, of pie. Then there are 5 pie chart types: pie, of pie, mentioned below here. Then graph and chart. Line charts. A line chart is the most useful for showing trends over time rather than static data points. The lines connect each data point so that you can see how the values increase or decrease over a period of time. The 7 line chart options are line, stuck line, 100% stuck line, line with markers, stuck line with markers, 100% stuck line with markers, or 3D line, like that. These are the mentioned in the figure. Scatter chart similarly to line graph because they are useful for showing change in variable over time. Scatter charts are used specifically to show how one variable affects another. Bubble chart, a popular chart type, is categorized under scatter. There are 7 scatter chart options: scatter with smooth lines and markers, scatter with smooth lines, scatter with straight lines and macros, scatter with straight lines, bubble and 3D bubbles, like that. Then area chart, like line chart, area chart shows changes in the values over time. Then stock, traditionally used to display the high, low, and closing price of stock. This type of chart is used in financial analysis and by inventors. However, you can use them for any scenario. If we want to display the range of a value, then surface and radar charts are also there. This is actually figure of the radar chart. Radar with markers, field radar. So in the today's discussion, we understand what is actually data and how the data is processed and generate information and how the data will collect from different sources, and after collection how can we transform the data to different steps, and how we store our data in a database for future purpose, and how we represent the data graphically. Thank you.